Hello, so very welcome back again. And this time we are going to talk about another interesting topic in the subject basic electricity and or basics of electricity. And the name of the topic is resistivity, or in more formal terms, we will call it as an electrical resistivity. So as you can see that there is this piece of material in front of you on your screen. It has got a length L, that is the distance as shown. It has got this cross-section area, which is indicated by letter A, which is also the product of width W and thickness T. So here you can see that this is a thickness of the material, a slab of a material, and this distance would be called as W, that is the width of the material. The material is a piece of resistive material with electrical contacts, one contact here and second contact here on its both the ends. So the resistance of this material is given by this formula. Remember, there is a difference between the two terms, resistance and the resistivity. So R is a resistance, and we will see in a moment what is the resistivity. So R, that is a resistance, is directly proportional to the L, that is the length of the material divided by a cross-sectional area, or you can also replace A with the product of W and T, which is right shown over here. So we see that resistance is directly proportional to the length of the material, and it's inversely proportional to the width and the thickness of the material. And we also can see that the resistance R here is proportional to the ratio of L over A, and here it is also proportional to a constant that is indicated by letter rho. So rho is the electrical resistivity of that material, and the rho can be given from this formula. We can write this formula: rho is equal to R into A over L, that is the area over the length. So we are basically converting this formula to this and vice versa. Okay, so here that formula I have written again here. So resistivity is the electrical resistivity. It is expressed in ohm meters, or simply in symbolic form ohm dot meter, where R is the resistance in ohms, A is the cross-sectional area of the material in meter square or square meters, and the length L is the length of the material in meter. So the resistivity is the fixed quantity that is decided by the resistance offered by the material, cross-sectional area of the material, and the length of the material. So longer the length of the material, lower the resistivity; higher the area of the material, higher the resistivity. So we have to understand that it is a property of a material to oppose the flow of electrical current through it. That's the very basic definition of the resistivity. So there are different types of materials such as metals, semiconductors, insulators. So based on that, which metal, semiconductor or insulator you are talking about, the material resistivity is given, and that is a fixed value for that specific material. So the metals have the lowest electrical resistivity. Obviously, metals are pure conductor of electricity. So resistivity, which is an inverse of conductivity, will be a lowest for all metals. And the unit of the resistivity is ohm per meter. Don't ohm meter, not ohm per meter. Don't get confused with only if you write only ohm, that is a unit of a resistance. If you write ohm dash meter, that is a resistance, the unit of resistivity. Okay, so there are few key points that we will remember here. The low resistivity materials such as metals, and they are all good conductors. For example, copper, aluminum, they have low resistivity. It means they allow an easy passage of current through them. Then you have high resistive materials such as insulators, for example, rubber, wood, or glass. They all exhibit a high resistivity. That means the current flow through them. Okay, and depending on it is a metal or insulator, they have their specific resistivity given by this letter rho. Another important point that you want to make here is the temperature dependency. So you see that for metals, the resistivity increases. It means the conductivity decreases if the temperature goes up. So if you heat a metals such as aluminum or copper at a higher temperature, they become less and less conductor because the resistivity in them is going up. So they will become more resistive material. Okay. But in semiconductor, for example, if you take a piece of silicon or germanium, and if you hit them with increasing temperature, their resistivity will go down. It means they become more and more conductive material. That means they will allow the easy passage of current flow through them. So that's the difference between conductors and the semiconductors in terms of their resistivity and their relationship with the temperature. Okay, so let us move to next point. So you see that we have got this piece of resistive material again with electrical contacts on both the ends. So here we can make another statement that resistivity is an interesting intrinsic property of the material. It means it is inherently there and it is fixed. Its value is fixed. But now there is this formula that we see the resistivity is R multiplied by A over L. It means it is proportional to the resistance of the material. It is proportional to the area, cross-section area, and the L, that is the length. It is inversely proportional to the L. But then we are saying here, it does not depend on the geometric properties of the material. And the formula here indicates this relationship. So how to understand that? We can understand it here in this way, that the resistance is proportional to L over A, but not the resistivity. So if your A over L or L over A changes, the resistance will change accordingly. And then with the resistance change, you have a specific resistivity for a specific value of a resistance. However, uh, for a for a given material, then for each different types of material, the resistivity is already fixed here. Okay, so for example, let us take an example of copper wire, that is a CU wire. So we see that these copper wires not subjected to any stress or distortion in their crystalline structure. It means the atomic structure is not altered or disturbed. So irrespective of the shapes and the size of these copper wires, for example, you see here there are different types of copper wires with different shapes and size. So they have the same resistivity. Okay, so it means if it is a copper wire, depending on how long or how thick or their cross section area is, they have a fixed value of resistivity. That means is this. However, if we talk about the resistance of these different types of copper wires with different shapes and sizes, we see that if you have a longer copper wire, they will have a larger resistance because of this formula. R is proportional to L over A. So L is the long length of the material. So for a longer copper wire, you have a larger resistance. However, if you have a thicker copper wire, for example, it's quite thick as compared to this one. So it means for a thicker one, A cross-section area is big because A is W into T, what we see before. So if the T increases, resistance is smaller. Okay, so for a shorter wires like this, if you have a short wires, they will also have uh, because their width is now the shorter one. This, you see, this is the width over here. They will have a larger resistance. However, their resistivity is fixed. For copper, all different types of copper, they have only one value of resistivity. Okay, so here again we see that every material, they have their own characteristics resistivity. As I said, for example, if you take a piece of rubber, here it's a pure insulator, it has got a fixed value of resistivity. And if you compare this insulating material, which is a rubber, with that of a conductor, which is, for example, copper, the rubber will have a far larger resistivity than the copper. Okay. Another piece of statement here, the conductivity, mho, is the inverse of the resistivity. Mho is equal to 1 over rho. So that's the formula you need to remember. Okay, and the unit of the conductivity is Siemens per meter. That is S over M. And the unit of the resistivity, as we've seen previously, it is ohm meter. So you have to. So hope you found this model useful. If you did so, share it with others for wider reach. And stay tuned for more engaging content like this. Till then, wish you happy learning. Do consider joining our membership of the channel. We have got members only exclusive videos, and you also can have access to the PDF notes, which you can use for the studies or professional experience or whatever you want to like. We also, by joining membership, you will also have a priority reply to your comments on our content. So stay tuned. Till then, wish you a very happy learning.